Okay, I think we'll get started. A little bit of housekeeping. I've mentioned that we want everyone's cameras and mics off, please, so we can just focus on the speakers. We'll be recording this and sharing it on a couple of places, including our YouTube channel. We will be taking questions at various moments throughout the presentations from our speakers, but we could put them on in the chat, please. We'll then triage them and ask them to the presenters, and we'll get started. Okay, so first of all, welcome to the webinar series. This is the last of 7 advice webinars we've had, and these are on individual grant challenges, which I'll go into later in detail. I'm Stephen Haven. I'm a senior AI consultant at the Energy Systems Catapult, and also presenting from our side will be Beth Warnock, who's a senior power systems engineer here. We'll have 3 groups of speakers as well from various organizations who are going to be demonstrating how they've used AI in enabling net zero infrastructure, and I'll introduce them as we go along. So a little bit of a breakdown of the agenda. There'll be a very quick introduction to the advice program from myself before I pass on to Beth, who's going to look at the sort of background and the challenges for how we build new net zero infrastructure. And an overview of how AI can support that net zero infrastructure. Then we have 3 groups of guest speakers from 3 organisations: Continuum Industries, Scottish and Southern Electricity Networks Transmission, and the Energy Networks Association with Baringa. And then we have a close down and next steps on that. Very briefly, I don't want to spend too much time on this, but if you're not aware, we are members of the Catapult network. We are the Energy Systems Catapult, also obviously focused on energy systems, but there are 9 catapults, each focusing on different areas where the aim is to support innovation in the UK and wider. And we also are looking at trying to bridge the gap across the sector between academia, industry, and policy. If you want to know more about that, then please get in contact. Okay, so Advice is the AI for Decarbonisation's virtual centre for excellence. This is a DESNZ-funded project, which is worked on between ourselves at the Energy Systems Catapult, another catapult called the Digital Catapult, and the Alan Turing Institute. And the aim is to look at where we can use AI for decarbonisation across various sectors. In this case, 4 particular sectors: energy, built environment, manufacturing, and agriculture. With obviously our focus on energy and built environment. The aim is to look at the landscape, understand where AI is being deployed, understanding what challenges and use cases there are, and also to try and encourage sort of dissemination and collaboration across the sectors. We have reports in these areas, and my trusty colleague Sam Young will be sharing some links in the chat, so that you can click along and find more resources there. But I'll also have some QR codes on here that you can link to if you wish. A little bit about what we try to focus on in terms of the challenges. Obviously, we were interested in the overlap between AI and decarbonisation, but we were also interested in looking at it from a top-down and bottom-up approach. So we were interested in what were the big challenges in decarbonisation, and then looking where AI could be applied, and then also looking at where AI is being applied and how that can sort of support decarbonisation. So in addition to looking at individual obvious examples of where AI could be applied, we were also very interested in looking at systemic blockers to decarbonisation. And I'm very pleased that many of the talks you'll hear today will be demonstrating how they're pulling down some of those systemic blockers. I mentioned earlier that there was sort of 7 grand challenges which we identified. These are all areas where, in those 4 sectors we mentioned, there is significant contribution to emissions, and these were areas we thought AI had a lot of potential for supporting the decarbonisation in those areas. This is obviously number 2, enabling net zero infrastructure. But we had 6 others, and we've had 6 webinars prior to that. All of those are listed. They'll be on our Knowledge Hub, so you can access them from there. And they're also the two other energy ones are on our YouTube if you wish to look back at those. Obviously, one of them that is most closely linked to this today is the Maximising Flexibility in Energy Networks, which looks at sort of supporting that infrastructure once it's built. We also devised a lot of individual tasks where we think AI can be applied. We created sort of a deck of cards for these, but also some virtual challenge cards if you wish to look at those. They look at sort of areas where there's specific tasks where AI could be applied, where they could have particular. We looked at sort of what size impact we thought they had have, how suitable we think AI could be to solving them, but also the novelty. We're always open to adding more to this, so please get in contact if you think we've missed off some key tasks, and we're always looking to update that virtual set of cards. Okay, so that's it from my introduction part. I'm now going to pass over to Beth, who's going to talk us through the sort of context for building net zero infrastructure, and then I'll introduce the speakers as we go along. Take it away, Beth.
Thanks. So if you just move on to the first slide. So I wanted to start by talking about, what does decarbonisation mean for the electricity network? One of the really big parts around it is that we're reducing the number of energy sources that we are using. So on this slide, I've kind of created an example around the home. So today, I use electricity for, lighting, washing, cooking and those kind of things. I have a petrol car and I have a gas boiler. But as I decarbonise my home, I will keep my electricity usage, but I will also be changing my petrol car for an EV and changing my gas boiler for a heat pump, which means that I will have gone from using 3 sources of energy within my home just down to a single source of energy, being electricity, and that will will increase the demand on the electricity network. So kind of what's the impact of this? Well, first off, our network will need to increase the capacity that it has. So that will mean building more network to be able to meet kind of increasing demands that we're expecting. Actually, the number of connections into that network will increase massively. If you think about every EV charger that might need to connect, I've just used an example of the home here, but also kind of thinking about other forms of transport as well. So a lot more connections will be happening. The type of demand that you'll be seeing on the network is also changing, and that can bring some kind of interesting opportunities. So, for example, EVs will form a different type of demand. It might be less easy to predict when they might be charging, but also having a battery available as well presents kind of a new opportunity for how that asset might be used to support the network. Heating demand is a very different type of demand for the electricity network, where today there is a connection between electricity demand and the weather. But when we start to electrify more of our heat, that relationship between demand and weather will increase. So when it is coldest, when it's been snowing for days, our heating demand will be at its absolute highest, and we will have very little diversity in that heating load, as everybody will want to be heating their homes at the same time, and the network will need to be ready to manage that. We're also changing how we operate the network and how we approach operating the network. The National Energy System Operator was created last year to create independence and take on new responsibilities, along with the creation of the distribution system operators, who are looking at how to operate the distribution network differently to enable more flexibility to kind of come forward and to be able to utilise the existing assets that we have in the best way possible. Another really kind of big change that we're experiencing is the kind of flexibility that we might expect to kind of see in the future. And so I've kind of talked about needing to build more network, but there might be opportunities to do that in a different way. So if we can move on to the next slide, please. So one of the big challenges that we have at the moment is around how quickly that we can build new infrastructure. Last year, Energy Systems Catapult published the Electricity Network Commissioner Companion Report, where we made a series of recommendations to half the time it takes to construct new transmission infrastructure. We identified a number of blockers that is kind of leading to a very long time in which to kind of build the network. The diagram that you see here is the process that we proposed, along with the recommendations that we had around it. And I kind of just wanted to highlight, just even within the kind of how you construct new transmission infrastructure, there are lots of opportunities for where AI can support. And today you'll kind of hear about where it is already supporting in kind of reducing the time it takes today. So kind of, for example, being able to use automation and AI to support how we design the network, how we identify the best places to build new infrastructure, and what type of infrastructure should be built. There are also kind of opportunities around how we conduct environmental surveys and how we share that information between different parties all needing that same information. Also, for processes like the planning approval process, how can we make the best use of AI to support how we fill in forms or extract information to help reduce the time it takes to kind of get to the bits of information that we really need to help with our kind of decision making. And there's also lots of opportunities within the build process as well. So starting to think about how we might design assets differently to kind of include things like monitoring and how we might then use that type of information to help inform decision making at a later point. So these recommendations are kind of currently being implemented at the moment. So kind of there is lots of change that's happening around this process at the moment. So lots of opportunity as well. If we can move on to the next slide. So I've looked at kind of like the building process, but I also kind of wanted to kind of take a step back and to start to think about the applications that AI can have, across in a wider context. So the first pictures are kind of around, having those different assets within the home. So kind of thinking about how we heat our home, and EV charging. So AI can potentially help with how we aggregate assets, how we can give real-time information about flexibility that's available to our control rooms. It can also start to think about how much is available straight away or potentially in a short or in the future. We can start to think about how we calculate risk in a different way. Moving into kind of thinking about the assets, how we model the network, it is still a fairly manual process for updating our studies. There is lots of potential for how we start to automate how those studies are run, to be able to extract more kind of useful information by being able to do more runs and to be able to look at more scenarios. Asset monitoring, and then how we think about how we use that information about how the assets are behaving, and can help us move into more condition-based asset maintenance as opposed to relying on a kind of static maintenance schedule. And also starting to helping us to start to predict where we might expect faults to happen, or where we think that it's most likely that a fault will develop in the future. Another really big area is around forecasting. So our demand is changing, and so being able to understand what our demand is going to be at any point as it potentially becomes less predictable. Renewable generation is not as predictable as kind of thermal generation that we've had in the past. And also kind of that reliance, the dependency of what the weather is and the temperature with what our demand might be at any point. So these are kind of like all opportunities for AI to kind of come in and help and support the decision making and kind of that awareness of what is happening on the network. If we move on to the next slide. The area that I thought that was, the next kind of big challenge where AI can support was around how we understand and calculate risk. So currently within our system operations, so within the NESO's control room, very, deterministic rules are used to manage the network risk. So, for example, across a constraint boundary, we would look at, if we were to have a fault, what would be the resulting flow on another circuit, and to make sure that that stayed within an acceptable level. I think that AI could start to support a more probabilistic approach to our risk management. So actually, what is the probability of that particular fault happening within the next hour or within the next day? How is the changing of the weather going to affect the risk that fault might occur? There's a big difference between a very calm and still sunny day and storm conditions. So what's the difference in the probability of that fault happening in those different times? How is the change in generational demand that we're seeing, how is that going to change the probability of that fault occurring? So I also wanted to think about, a specific use case for why this approach would be helpful. So I've got the example of, could you hold reserve behind a constrained boundary? So we currently would hold reserve generation in reserve, so generation that could come on very quickly should another generator kind of have a fault and kind of come off. So we need to make sure that we have sufficient reserves. For example, if our ScotEx boundary, so the boundary between Scotland and England, was constrained and we would be constraining generation in Scotland, you might decide to not hold any reserve there because it would result in further curtailing wind generation there, and therefore you would hold the reserve in England and Wales instead. But if we kind of move to a probabilistic approach, actually, could we start to think, well, could you hold, 200 megawatts of reserve in that area? Because actually the probability of that fault happening within this time frame is sufficiently low that it's okay to do that. And so I think that this is an area where more work should kind of be focused on, to kind of start to think about it. The benefits of moving to this approach are kind of being able to manage our network in a different way, which could potentially save on constraint costs as well. So if we can move on to the next slide. I did want my final slide to start to think about actually what is the limit of AI. I think there are lots of possibilities and they're all extremely positive, but should we be moving to a world where we really rely upon AI, or should we start to think about what limits there are to it? So I wanted to use the example of an autopilot on a plane. On a plane, an autopilot can take off, it can fly the plane, and it can land the plane. It can probably do a better job than the pilot a lot of the time. And in a lot of ways, when we've kind of thought about our AI applications within kind of system operation, it would be very similar. The majority of the time, that support and the kind of, an automated process would kind of like optimize the system very well. But what happens in an emergency? And AI can't necessarily take in the same information or understand a situation in the same way that a human can. So in our example of an autopilot, in an emergency, actually a pilot needs to be able to take control of the plane and be able to make decisions. So the photograph here is, the example of a pilot choosing to land a plane in the Hudson River. That isn't a decision that the autopilot would have made. But in order for that pilot to be able to make that decision, they also need to be able to kind of keep up their skills and their experience. So they need to be able to take off, and they need to be able to fly the plane, they need to be able to land the plane. So they will need to take the autopilot off and do that manually themselves to keep up their skills and experience. I think that when we think about AI applications, especially within the control room and for how we operate the systems, a similar approach needs to be taken. We need to ensure that our control engineers still have the experience and they still have that knowledge, and that they still can operate the network without the need for AI as well. Simply because when an emergency does happen, for example, faults happen on the network, they will need to be able to kind of take back control. So I will pause here and see if there's any questions.
Thanks, Beth. I've asked for a couple of questions in the chat to both of us, I guess, here. Nigel's got one about, will AI give advice on the specific resources that need to be committed to the different statutory entities involved in the planning consent process to keep the critical path to its minimum period? Do you want me to have a start on this? I think, I don't see why AI, I think that's one of a great application for AI is giving advice and then a human to make the final decisions. I think we'll see some of those examples as well of where AI can do that. We've also got there was a brilliant talk that was given that maybe Sam can share, which looked at sort of building scenarios for sort of future net zero energy scenarios. And I think that would be a great one to share. It was from one of our value and energy data talks, and that shows that, yeah, it's definitely a real place where you can do that. I don't see why not. Joe from Energy Elephant has asked some feedback on the UK grid smart energy traffic light system. So yes, please have a look at that and feedback some definitions. For some give him some feedback. Dan has asked about what sort of definition of AI. I think this is a very wide and contentious subject. So I think we are going to be relatively open, and I do agree when you're saying that, yeah, it's important, that individual types of technologies have different risks and different advantages. They have to be assessed on a use case basis. We're taking it quite generally here in very much into data-driven type methods, which can assist sort of this challenge. And you'll see again from the talks we'll have that a variety of methods have been used, and they're very suitable for what they're being applied to. So there is obviously more and more regulation being considered on how AI should be regulated, and Ofgem are obviously devising some best practice guidance in that area. But of course, it's going to be an area where it probably needs feedback from everybody to make sure that it's being operated in the safest and the relevant opaque transparency that's required depending on the applications. As Beth mentioned there, in many cases we'll need a human in the loop to make sure, especially for the highest risk applications. Robbie asks, public processes are a key part of infrastructure build out. So how do you match presumably opaque AI analytics with public expectations regarding transparency and third-party validation? Again, I think it comes down to depends on the application, and I think for the infrastructure build out, I think again you'll see in some of I think it'd be a good question for some of our speakers later who are looking at sort of trying to support the networks and how they're trying to engage with stakeholders, and that's a key part of it. And in fact, I've just seen Sean has responded in the comments as well there, but maybe he'll address later as well.
I think on the transparency issue as well, I think if you look at the decisions that the control room make today, there isn't always transparency today about why a decision has been made, or why a certain asset has been kind of skipped over for another asset. So I think it is a challenge anyway that exists. But I do agree that that transparency and understanding is required.
Right, I'm just trying to get through the questions here. There is also a link from Gabriella to the Ofgem, if we could, the Ofgem consultation guidance. So that's very helpful. David Orr asks, would AI pass a line-by-line code check, which is required for safety-related systems? That's an interesting question. I think there is going to be definitely a require for the appropriate review systems, and I think if we're talking about higher risk applications, there might be a requirement here for some third-party assessments. And I think, if I believe there was some AI assurance guidance that had been published from the DSIT, there's some suggestions that this is appropriate to sort of especially use sort of third-party reviews where appropriate. I think going into more detail that might be difficult without thinking about that a bit more. Okay. Well, thanks very much for the questions. Hopefully, as well, more of the questions will be answered, and more questions will occur as we go along. I believe that we have Continuum are going to share their own slides. So I'll let them set up that as I do a quick introduction.
Sure thing.
So yeah, can I welcome Continuum Industries, which is Adam Energeski, Andreas Malekos, and Sam Watts, and they're going to be presenting their platform, which utilizes AI to accelerate infrastructure planning, site selection, and optioneering for energy infrastructure and grid connections. So take it away.
Right. Thank you very much. Just double checking, I'm coming through okay, and the screen is being shared all right as well, right?
Yes. Yeah.
Perfect. Okay. Good afternoon, everyone. My name is Adam Aniszewski. I'm one of the co-founders of Continuum Industries. So we're here today to tell you a little bit about what we do and how we have applied our technology. That is called Optioneer. So the plan for today, just showing you here, is to recap why we do what we do, who we are, what we have done so far, and then I have my two amazing, very clever colleagues who will actually talk about the AI applications in our product. So Andy and Sam. Right. So as a recap, and I think that we by now are all well aware and understand the need for net zero. Something that sometimes escapes people's attention is that, well, that will require a lot of new transmission capacity. As we know, one of the themes that Beth had spoken about was about enabling net zero infrastructure, and that is exactly what we help our customers do at Continuum Industries. So what have we got? We've got an AI-powered platform for transmission development, and so far the company has existed for the last 6 years. It has been founded out of University of Edinburgh. So we were all students at the University of Edinburgh where we met, and eventually had set up a company and scaled it up to now operations across Edinburgh, London, and New York. And we have worked with multiple customers across UK, Europe, and the US. So the platform that we call Optioneer, very hopefully a good name for a software that is helping people with optioneering, has so far been used across multiple countries, multiple utilities, over 100 projects, over 60,000 of kilometers of project asset options were evaluated. And it's not only used in the electricity sector, it's also used for hydrogen, CO2, water pipelines. So basically anything that's a line on the map that is not transport of humans, so not roads or railways. And we also, by kind of company choice, work only with sustainable infrastructure and infrastructure that leads to net zero. So avoid oil or any new developments or extraction. Right. So one thing that I wanted to explain is that our software, because there were a lot of questions about that, does not make decisions or tell anyone what to do. We have a software platform that I'll introduce in a moment that helps all of these different types of experts make decisions and move a little bit faster. So it crunches a lot of numbers, it summarizes a lot of analysis and reports, but there is very much a human in the loop that is maybe not verifying line by line the AI code, but is verifying line by line the outputs of whatever comes out of our product. So the three main groups of folks that we work with who work in the development of new transmission infrastructure would be on the technical side, engineering side, permitting or consenting or stakeholder engagement, as well as environmental folks. So some of the job titles that would normally use our platform, you can see them on the left, sorry, on the right. And one of the reasons why we do what we do is because there's a lot of work to be done in order to support the transition to net zero, and not that many experts around. I mean, there is quite a lot, but still, for the uptick in the amount of work that needs to be done, the industry needs new tools, new processes, new clever technologies to make sure that the decisions that are made are optimal, that all the options were explored, that they take into account the voice of local communities and third-party stakeholders, and that they do the best thing for the energy system as well. So what we want to do is that we want to integrate all of these disciplines more and allow them to iterate faster and make better decisions. But design of infrastructure, especially transmission infrastructure that spans across tens of miles across the country, often, sometimes hundreds, is a very interdisciplinary challenge that has to involve all of these different stakeholders. And where we work predominantly is in the very early stages of projects. So before you go into procurement and kind of involving your contractors. So that means when planning, design, options assessment, as Beth was showing, corridor route development, reporting, preparation for consenting, public consultation, stakeholder engagement, where all of that is happening, this is where Optioneer thrives. And the reason why we went after that type of application is that we found that this is really where, if given better analysis, better data, we believe that experts can make decisions that have the biggest influence on the program, the ability to deliver, minimizing all the adverse impacts of infrastructure, and basically the leverage is the biggest. The deeper you go into the development process, the more difficult it is to change the decisions. Early stages, the decisions can be changed relatively easily, shall we say, but there's often not very much time or resource assigned at the early stages. So hence, again, us wanting to bring a tool that leverages all of this powerful technology to give these interdisciplinary experts the ability to make the best informed decisions as early as possible in the process. So normally the process is fairly linear. It will go through a variety of stages. Again, as Beth was showing, we're trying to compress it a bit while at all not compromising quality. In fact, increasing the quality of analysis and the level of detail that customers using our software can look into. And then in case of any changes or feedback from stakeholders or communities, so that they can redo their analysis quickly. So we find that coming up with options and routes and corridors isn't a one and done job. It's a constant game of reworking, rerouting, acting on the feedback from local communities, acting from the feedback from stakeholders, and combining both the data-driven, algorithm-driven analysis with what's on the ground, the human expertise and the local expertise and in general. What is also very important for well-functioning type of AI analysis is the data. So we as a company, we have a lot of partnerships with some of the reputable bodies who might be even represented on this call, who publish authoritative data around spatial constraints, where environmentally protected areas are, where people might live, where historical sites are, and so on. So this is a strong foundation for us being able to take into account as many views and stakeholders as possible and give that very strong data-driven, evidence-driven foundation to the experts that will be making these later decisions. So I just wanted to say that this is not, the AI going and Googling, some sort of rubbish information and passing it on back to our users. In fact, we have internal experts who verify the data coming into the platform, and then the data comes from reputable sources, and then is kind of reworked into insights for the users of the platform. And some of the users, and again, I think some might be even represented on the call, and we have our friends from Scottish and Southern Electricity Networks Transmission. So these are some of our customers that have used the software across a variety of different projects, from early stage design of networks to later stages of development. For obvious reasons, I cannot go into more detail or too much detail about it, If there are any specific questions, if you're from within one of these organizations and you would like to find out the work we have done with your colleagues, then please just get in touch. You can drop your details in the chat, and one of our team will follow up with you if you're interested in what we do. So I'm almost ready to pass on to my colleagues who will be talking about the practical technical elements of how we apply the technology, but I just wanted to kind of reinforce the fact that it's not just AI doing AI things. It is a lot of outputs, a lot of analysis, a lot of data that is presented in a digestible format for experts to make the best decisions possible and to save them time. Because if we save their time, then they have more time to fix the difficult problems rather than crunch numbers or seek for data on the internet. And that's the mode of operation for us. And one of the examples here, actually, as I mentioned, from our friends at SSEN Transmission, we have a case study showing a 2/3 time reduction in one of the stages of the project, sort of simply by the virtue of bringing all of the information that experts should have, deserve to have at their fingertips and letting them do their job efficiently. Before I kick off with my colleagues here, I just wanted to kind of close this out by saying that there is many types of AI, and there were also questions about this in the chat, so this is a timely share, I believe. And this is just to let you know that the different types of technology that my colleagues will be introducing might be living in different places on this tree, and we have chosen technology that is the most fit for purpose, that is auditable, that protects our customers' data, and we're not doing AI because it's cool, we're doing AI because it solves problems. And with that in mind, I will let Andy and Sam take it away. Thank you very much.
Cool, thanks, Adam. So I will proceed to share my screen now. It's basically the same slide deck, but just a bit easier if I'm the one sort of pressing all the buttons. Wait, is that sharing?
You just have to click as well.
Yeah. Okay, let's try it again. Oh, don't do that to me now. Share window.
Yeah,
there we go. Can people see?
Yep, can see that.
Yeah, perfect. Okay, so hello everyone. Good afternoon. So I'm Andreas, or Andy for short. I'm the head of AI at Continuum Industries, and over the next 5 or 10 minutes, Sam and I are going to kind of walk you through some of the different types or some of the different applications that we use AI for within Optioneer, the software developed by Continuum. So I will talk mainly about what we call our routing engine. And how we use, in this case, a particular type of AI called evolutionary algorithms to basically power an algorithm that can solve complex routing infrastructure problems. It can do so for different assets. So Adam mentioned transmission lines and the need to sort of build new transmission for sort of the net zero transition. But we also do things such as water pipelines or offshore power cables, or even other types of pipelines onshore. It can take into account different design considerations, and it can also operate across different geographies. And I will expand across all of these in just a second. But first, a brief introduction to sort of what evolutionary algorithms are and kind of why we're using them. So they're basically a family of optimization algorithms that are inspired by natural selection. That's kind of the broadest sort of like definition you can give them. And this is kind of like a bit of a schematic, a diagram of kind of how that works. I'll go through it sort of very briefly. Here's the sort of the same diagram. Basically, the way that it works is that these algorithms sort of work on what we call a population of solutions to a problem. And essentially, they will create a random set of these, what we call candidate solutions. And they will evaluate each of these candidates against what we call the objective sort of function. So in our case, being transmission lines, how expensive is a transmission line to build? How feasible is it to build, right? We will then use that information to select a set of the top performing candidates. And then from these candidates, we'll do what we call a recombination process. And we'll combine the features of the best features of the top candidates and create a new candidate. And the idea is that by doing that, we will create a new population of possible solutions to this problem that should be overall better than the previous one. And this process kind of repeats and repeats and repeats until we have converged into a set of good solutions. So if you sort of like click once, I think there should be like an animation that comes in. If you click again, see, this is why. Okay, yeah. So here's a little animation demonstrating this for like, a sort of toy problem. So in this case, these little sort of cute dinosaur thingies. So imagine that like you have an algorithm optimizing those. So the first one falls immediately. After a few generations, moves forward a little bit more, but falls again. After 80 generations, we're getting there, but it's kind of, it's sort of a bit wonky and wears off to the end. And at the last generation, we have something that is sort of like working quite well. So if you could move forward again, please. So yeah, basically, this algorithm can take as an input geospatial data, so information about where do you have forests, where do you have buildings, where do you have environmentally protected areas, the elevation at each point, the slope at each point. It takes into account what we call design rules. So these are the things that define basically the rules of the game. So in the case of transmission lines, things such as what is the height of a tower? What's the spacing you would like between towers? After which angle change should you be placing a different type of structure? Under which type of geospatial data should you, instead of building a tower, actually digging underground? And what kind of digging? So these are the design rules. In these, we'll add sort of unit costs, so how much it actually costs to do all of these things. And then the routing engine will do its thing through the evolutionary algorithm. And at the end, we'll get a bunch of outputs, which I will walk through in a moment. So if you could go to the next slide, please. Yeah, so what does it look like in our case? It looks a bit like this. So forget about the dinosaurs that I showed before. This is kind of a real example of our engine working. So it starts with a really sort of high number of random, essentially, routes. And as you can see through this animation, sort of eventually kind of converges and refines this sort of like really large number of routes into quite a narrow set of possibly good alignments. So next slide. So why do we do this? And here, like, if you could just kind of click a little bit and we get, yeah. So why were we using this method, basically? So first of all, we consider that exploration is more useful. Yeah, that should be everything. Whoop, one back. Exploration is more useful than optimization. So basically what it means is that the best solution is subjective. And in fact, it really depends on the kind of data that you're giving our algorithm, but it also depends on the model that we have built to try and represent how good a transmission line is through space, right? And that model is not perfect, So even if we were to build an algorithm that guarantees the best sort of like result for the problem that we give it, that problem is not a perfect representation of reality, right? So it's going to be the best solution to an imperfect representation of reality, therefore not really the best solution. Therefore, it's better to give options rather than to give like one route. And that's kind of what you can see on the right here. You've got like multiple sort of like, we'll try to find multiple paths, basically, and try to give users information about each of these paths that allows them to make a decision about which option is the best for them, right? So that's one reason. Secondly, is that this type of AI doesn't need training data. And therefore, it doesn't really carry the same risks around data privacy. So we don't need to like harvest, your data in any way, shape, or form, because there's the concept of training or of using that data to make the algorithm better doesn't really exist for this type of algorithm. So basically, you run a case in Optioneer, you get back the results, and that's it. And all the data sort of like remains there. We don't need to sort of like save it for any other purpose, rather than just doing that one-off analysis. And then last but not least, it's agnostic to the objective type. So basically what that means is that the algorithm doesn't really know what it's optimizing. It takes a solution, it makes a change to it, it evaluates it, and then it moves on. So that means that we can basically really customize the design considerations that it takes into account and really sort of build a lot of, like, use it for a lot of different use cases. And I'll go into those use cases in just a second. If you could move to the next slide. One last thing before we move to the use cases, is that we use something called multi-objective optimization. So what does this mean? This means that essentially in our problem space, which very often is where do I place a transmission line, different stakeholders will care about different things, right? Local communities don't want to see the transmission line. Environmental experts want the transmission line to have the lowest environmental impact. Engineers need the line to be constructible, to be feasible, right? And each of these people, if you're to ask them, where should the transmission line be placed? They'll give you like a different answer, right? And more often than not, these answers are going to be opposing to each other, so completely different. And it's difficult to say immediately how much you care about one thing versus the other. So multi-objective optimization is a way of trying to optimize for various goals. So you're trying to basically find the best solution for that's the cheapest one, and maybe the solution that has the lowest environmental impact. And then you're trying to find a bunch of alternatives in between that represent different compromises between these things. So that's the stuff you see on the right-hand side there. These dots are different solutions going from the cheapest but most impactful to the least impactful but most expensive. If you could move forward one slide. Oh, right. Yeah. So multi-objective is the answer. So a couple of examples of what this looks like in action. So here's some results from rural Scotland. It's quite a small scale connection. And in this case, we're balancing out the cost and the risk of adverse impact on the environment or the population. So what you can see here, obviously, you have these lines on the map. These are the different routes that we have found. But you also see what we call this heat map. And this heat map is an additional kind of output that we provide to our users so that they can get all of the context around where we think the best lines are, because we explore many lines, many possible alignments, and we can't return all of them to the user. So we try to kind of summarize that information in a way that's helpful, and so that even if a user, at the end of the day, users have the final say, right? They can grab one of these lines and iterate on them. So they have more information than just a line to make that final decision. You can move to the next slide. Another example here, again in rural Scotland, in an area of high visual amenity. And here we are balancing out two slightly different things. We're balancing out the cost and the visual impact of the line. So you see two lines there. The blue line is the one that is the lowest, that has the lowest visual impact, whereas the orange line is one that has a higher visual impact on the area, but is maybe cheaper, right? And again, here you see another example of a kind of output that we return that's not a transmission line, but instead is what we call this visual impact map, which in this case, blue means, not that impactful, red means high visual impact if you're in that area. So again, this helps users this gives users more context around the outputs that we produce, and also helps them make the right kind of adjustments. If they want to say, focus more on visual impact, they kind of know where in this area, the areas of low visual impact are. Next slide, please. Another example here, which is in California. It's a transmission network reinforcement project. And in this particular case, we're trying to balance out environmental and social risks against staying close to existing rights of way. So that's a very US specific, well, actually, I don't know if it's US specific, but it's very big in the US. It's very important that new infrastructure, if possible, stays within existing rights of way. So where permission has already been given to build transmission lines. So on the top image there, these lines are basically existing transmission lines. So therefore areas that have already these rights of way. And at the bottom, you see we have now the found routes that are sort of trying to stay close to these lines while also avoiding having too much of an environmental or social impact. So this is just to show basically all the different use cases that we can serve. And then there's one last one, if I'm not mistaken. So if you could go to the next slide. Yeah, so another sort of example from the US, in this case, the East Coast, where in this case, we're kind of routing through dense urban and suburban areas. So we don't just do greenfield and rural environments, but the algorithm is able to also handle quite dense urban areas, and in fact also navigate through sort of cities. I think we did a couple of projects, pilots, and also real projects, I think, in various cities around Europe and the US, where we were routing pipelines underground through a city. Yeah, next slide, please. I think that's me. Yeah, that's me. And now over to Sam to talk about some of the other applications that we've got.
Great, thanks very much, Andy. And yes, if you can click one more time, that means we can just stay without some clicking for a while. Wonderful. Yeah, hi everyone, my name's Sam. I'm an AI engineer at Continuum Industries, and I'm just going to talk through basically 3 slides of some different research areas that we've been looking at in the last year or so that kind of touch on a few different aspects of AI. We've heard a lot from Andy about our kind of core focus of evolutionary algorithms, but we've been experimenting a little bit more with some machine learning recently, and also using LLMs. So this first slide, I want to talk about the problem first before the solution. As Andy and Adam have alluded to, in the top left here, we've heard that our products optioneer, it produces a lot of data. So for each of our routing options, we get a lot of metrics and information about how each of these routes impacts particular areas. And within that, we know how much these routes impact particular data layers. So you can see here, for example, that These two hypothetical route options might cross ancient woodlands and broadleaf forests to a different extent. In conjunction with this, something that we've been building up internally is something called our permitting guide. Permitting is really important for our customers when dealing with governmental entities. They need to prove that they're building their infrastructure in a responsible way that conforms to all of the regulations of that particular area. So we've built up this guide which links the different permits in a region to these different geospatial data layers. And what this means in aggregate between all these option metrics and the permitting guide is we have this really rich data connection, which you can see at the bottom, between option metrics, geospatial data layers, and permits. They're all connected, but at the moment, it can be quite hard for a user to work out all of these different connections and how it links together. So if a user was asking these questions in the middle, like which is the best option when it comes to impact on woodlands in general, or which permits might be relevant to these options, this could be quite difficult. So we've been developing a prototype LLM-based chatbot, which is quite limited at the moment, but it allows the user to ask a question like, which is the best routing option with respect to impact on woodlands? And we produce a summary, but also proof of what backs up that summary. We've got this table here, which is comparing some options based on all of the metrics that we've established are related to this particular question, and then also linking the relevant permits and other information that users might find helpful. So next slide, please. And if you do a little bit more clicking as well.
Just so you know, there's 4 minutes left on the.
4 minutes, brilliant, thank you. I'll speed through a couple, yeah, that should be fine. The next thing we've been looking at is related to geospatial data. Adam mentioned that we have a lot of geospatial data baked into our program that we've acquired from various public sources, but we have also found that not absolutely everything that might be important to our customers is represented in this public data. So there's a couple of examples here of what we've tried to do is infer some of this geospatial data from satellite imagery using computer vision, so well-known machine learning algorithms to try and predict from a satellite image on a pixel by pixel basis, in the top case, where roads are. And then once we know where the roads are, estimating how wide they are. And in the bottom case, this is an interesting example of in the US. It's quite common in the center of the US specifically to irrigate fields with these long arms with sprinklers called center pivot irrigators. And this can mean that if a route crosses any part of the center pivot irrigation system, that field then can't be used in a productive way at all. As opposed to field crossings in the UK, where sometimes you can cross the edge of a field and the rest of the field can still be productive. So we've been doing some research here to try and work out what we can infer and like fill these data gaps that we currently find are there. And then next slide, please. I'll whistle through this last one as well. The other thing we found is that it's relatively common in projects for some geospatial data to not be digitized. Sometimes customers will have examples of important data that they want to include in the project and as part of their routing considerations in PDFs. So I've got an example here of Edinburgh. This is a proposals map published by Edinburgh Council. And say, for example, we wanted to extract this polygon in the middle that represents Holyrood Park. So usually there's a couple of ways you would do this with conventional GIS methodologies. You would first georeference the image. So we need to know, hey, like where is this image actually located in physical space in the Earth? That's pretty hard to automate at the moment. The thing which we have found easier to automate or semi-automate so far is to actually trace around that polygon and extract it or segmentize it. So we've done some work with the segment anything model, which was released by Meta 2 years ago now, with a decent amount of success. If you click a couple more times, what we're able to do with this model is prompt it almost in a similar way as you would prompt ChatGPT, but instead of prompting with words, we're prompting with points. So we're telling the model with our green points, hey, these points are inside a polygon that we want to extract. And with red points, these points are outside the polygon. And you can see in the bottom right for this example, this results in an actual some vector data that we're able to extract and actually put into Optioneer and use it for routing. And yeah, that's just kind of a quick fire through some of the non-evolutionary algorithm research that we've been doing recently. And yeah, thank you. I think I'll hand back to Adam and we'll open up to questions.
That was great. Thank you very much. I'll just try and group up a couple of the questions that's sort of in a similar theme here. A couple are about how sort of like the transparency may work here as well. Nigel Morris mentions here that will the optimization rules be published in public consultations to enable consultees to understand the reasonable alternatives and why those things are accepted? And that's also related to sort of Eric Brown's point as well earlier about, you know, to what extent can citizen groups be given access to the tool to explore options?
Sure, I'll take this one very quickly. So the optimization rules that the product is set up with can be changed by the user, so they can be aligned with the specific company's guidance on how they develop the projects, but the baseline is generally aligned with planning policy, best practices, Halford rules, any kind of government suggestions or advice that we have available to us. In terms of public access, it is something that is on the roadmap and in aspirations, but currently the tool is not directly available to the public. It's used by utilities. However, we have had it used in public consultations a lot and in stakeholder engagement. So not the public, but I think Natural England's been in quite a few times having a peek.
Okay, thank you. And I think just one more question, but wrapping up a few of these comments from David and Kojo here, is about the data. I'd be really interested to hear more about sort of your experience or challenges with getting all these data sets together, you know, and checking their quality and, you know, how you work with the partners to sort of put these data sets together.
So I think people like to complain about Great Britain a lot, but one thing that it has is great availability, public availability of data. So starting with great institutions like Ordnance Survey, all the way to various government bodies who do publish their data, which is generally speaking of high quality and well structured. So we use this data the way that any consultant, any contractor, any expert in the field would, generally speaking. We validate it against any site walkovers or any information that the user might enter. So it is generally speaking an iterative process that we've developed over time. There isn't like a one process that we apply for every data partner, but most of our data partners are indeed actually reputable, authoritative data providers that have links to the public sector. And that data is publicly available, so it's not like we're getting a special deal. We're just good at aggregating it and structuring it so that it makes sense to our users, specifically in the context of development of sustainable infrastructure.
And from the technical side, is there any lessons learned or interesting insights you think from that?
From working with the public sector and the data
all the data that you put together for this, I guess.
That it basically is quite difficult once you start moving across countries, because countries have different approaches to it, and it so happens that the UK consists of multiple countries, so it was a good testing ground for us. But I would say maybe the main lesson learned, anything that you build between Scotland or England and Wales, you start getting into kind of challenges around definitions. But I think we managed to crack that.
Brilliant. Thanks very much. There's a lot of questions in the chat, so if you could go in there and please answer as many as you can, that would be great. I think we're going to have to move on, but thank you very much for the Continuum Industries team. That was really interesting. There might be some time at the end as well for further questions. Okay, so without further ado, I'll move on to our second speaker today. So I'm very happy to introduce Sean Hodge, product owner at SSEN Transmission, and he will be discussing their AI feedback and sentiment analysis tool, which is helping to accelerate responses to customers, stakeholders by analyzing vast amounts of public stakeholder feedback. So I'm happy to click through for you.
Thanks, Stephen.
Sean, if you're there.
Yeah, thank you so much. Okay, so let's kick off and begin with a question. What if you could engage more stakeholders, gather better insights and make faster decisions, all with fewer resources? Well, at SSEN Transmission, that's exactly what we've done by embracing AI, which is a brave thing to do as a networks business, which are not historically known for being cutting edge, but something that we're definitely looking to change, as you've seen today. And today I'll be walking you through how we've streamlined and improved the analysis and categorization of stakeholder feedback using AI, allowing us to achieve greater impact with less time, effort and cost. And now I've got your attention, a quick introduction from me. I'm Sean Hodge, like Stephen said, and I'm the product owner for the Customer and Stakeholder Directorate at SSEN Transmission, which is part of the wider SSE family. And it's my job to lead on digital projects that help streamline how our connections customers, like wind farm developers, connect to our network, while also improving our engagement efforts with local communities and wider stakeholders using technology. And that's to ensure that their voices are heard throughout the development of our net zero projects. And I'm thrilled to showcase our recent AI feedback and sentiment analysis project for its innovative application and real-world impacts, and really share with you how AI is already changing things for us at SSE. Go to the next slide for me, please. That would be great. So who are we? I've mentioned SSE, and Adam mentioned SSE as well. Well, SSE is one of the country's oldest and largest energy companies. During World War II, the Hydroelectric Development Scotland Act of 1943 brought the North of Scotland Hydroelectric Board, NOSHEB, into existence, which later became Scottish Hydroelectric, which you may have heard of, which is now known as SSE today. And this act sparked an intense programme of new grid construction back in the day. And today, SSE is responsible for the generation, transmission and distribution of electricity in different parts of the country. And we've got a clear focus on delivering the energy that we need today and tomorrow. And SSEN Transmission is part of SSE that I represent, and we operate the electricity transmission network specifically in the north of Scotland, just for context. Next slide. Okay, so focusing on SSEN Transmission, like I said, we operate the high voltage electricity network in the north, transporting power from renewable energy generators like wind farms onwards to homes and businesses across Britain. And we build and maintain the infrastructure that ensures clean energy flows efficiently, connecting Scotland's renewable potential to the rest of Britain where it's actually needed. And while our work is critical for meeting national climate targets and keeping the lights on, we're often the company behind the scenes that very few people know about, but everyone depends on. And you can see the section of the energy network that we look after, where the pylons are showing on the top right-hand corner of the screen just there. Okay, moving on. Let's talk about our company's main goal, which is about delivering a network for net zero. If we go on to the next slide. So our entire business strategy at SSEN Transmission, it's about delivering a network for net zero. That's about enabling over 15% of the UK's total carbon reduction that's needed to achieve national net zero targets. And that's a huge responsibility for just one company. But just as important is how we do this. And that's in close collaboration with local communities and stakeholders across the country, especially in the north of Scotland. And our accelerated programme, known as ASTI, that translates into building 3 brand new 400 kV overhead power lines, 12 sizable substations, and several network reinforcement projects, all while connecting a growing number of onshore as well as offshore wind farms out in the North Sea, as shown on the map on screen. Next slide, please. Okay. Now, all of our projects require extensive consultation with the public to ensure that community voices are heard, valued, and importantly, acted upon. And our community engagement teams, headed by the wonderful Leslie Dow, who can't make today's meeting, Leslie and her team have engaged with over 300,000 people living near our project locations. They've hosted more than 220 in-person events in village halls, community centres, and other locations. But importantly, we've received thousands of online feedback forms through our public-facing website that I manage, as well as unstructured free-format emails coming into our dedicated teams. And as illustrated in the images shown on screen, this process can be very contentious, with members of impacted communities campaigning against or looking for changes to be made to our large capital project plans, the proposed power line routes, the locations, and that really emphasises the importance of our transparent engagement efforts. And our team is genuinely committed to getting things right for our communities, especially as residents of Scotland ourselves. And we take this challenge seriously, particularly when it comes to ensuring a positive outcome and future for local communities in the north of Scotland. And in today's world, this is essentially a continuation of the tremendous work that was done to build the grid work back in around World War II, but this time even more to build, and innovative technology like AI available to help us do that. Okay, move on to the next slide for me. And then on screen, I have some really powerful images of impacted communities who reside within our network area, which really brings to life the business challenge that we're all working to overcome at SSEN Transmission. And if we move on to the next slide for me. So we're now going to take a look at our AI project goals specifically. If you go on to the next slide. Okay, so above all else, our main goal is to get things right for local communities and wider society. But at a project-specific level, in relation to AI on this project, our primary goal was to explore how AI could accelerate the analysis of public feedback and consultation emails for ASTI projects. We aim to enable faster, data-driven decision-making in project planning and development, while simplifying the understanding of analysis and categorization, which is really important. Equally important was demonstrating our commitment to ethics, transparency, compliance, and data security. And by adopting responsible AI practices, what we did, we sought to build public trust during this critical and often contentious period, but especially given the novelty of AI to lots of stakeholders and different people. So we set out to replicate the high quality, trusted, human-led analysis conducted by our community engagement team. Got one or two people from that team on today's call, which is great. Using AI to achieve excellent and objective results more efficiently. Objective analysis being key here. And another key objective was also to avoid incurring significant costs, potentially hundreds of thousands of pounds on recruiting additional people for manual feedback analysis. Costs that would ultimately be passed on to GB energy consumers. Every penny that we spend at SSEN Transmission is passed on to GB consumers, for those who weren't aware. But at SSEN Transmission, we're working under accelerated timelines to deliver critical projects. And that covers everything from developing plans, procuring cables and vessels, to recruiting workers, building accommodation. Every aspect of what we do at the moment is fast-tracked to beat the climate emergency and reach these net zero targets. And that includes the analysis of public feedback and addressing stakeholders' concerns in local communities. And by implementing the AI tool, we've transitioned from fully manual analysis to faster, more effective hybrid approach that combines human expertise with AI-generated insights. And actually, that's a really important point that was made earlier in the chat, which is we're not replacing what people do. We're just combining AI-generated insights with our human expertise, which I think is the key to the success here. Okay, so moving on to the next slide. This is about just take a look at what we actually did and tell you more about that, if we can move on. Okay, so firstly, it's worth highlighting that this project was not part of our original business plan to deliver in 2024 last year, but it emerged as an innovative offshoot of another system that we're building in the customer connection space using Microsoft Dynamics 365. We recognised there was potential for to use AI to improve our feedback analysis work that we do in a different team. So we leveraged Dynamics 365 alongside Azure OpenAI to create our AI feedback and sentiment analysis tool, as we call it. But from the outset, collaboration was key. We partnered with colleagues who were already experienced in analysing public feedback and correspondence to ensure that we captured the right requirements with support from our fantastic business analyst, actually, Fiona Trainer, who's on the call today. And together, the team developed the system in an agile manner, refining it iteratively to meet their needs. And this close collaboration ensured that the tool aligns seamlessly with existing workflows and ways of working internally. And that, we were able to provide meaningful value from day one. But for the first time, we introduced visualizations, automated analysis, and AI-generated actionable reports. And these have transformed how we process and interpret community feedback and improved our reporting capabilities that weren't possible with manual methods as well. The AI-generated reports and visualizations, they've been enthusiastically embraced by our teams. They absolutely love them. And they find them invaluable for understanding the public's material concerns, enabling more informed decision-making. And it's now much easier at navigating high volumes of feedback as well in one central system than fragmented spreadsheets that we had historically. Just moving on to the next spotlight on this then. So, sorry, go back a slide for me, sorry. Thank you. Our AI tool is designed to read and process the original text provided by stakeholders. And on the left-hand side of the screen, users can see that original text exactly as it was submitted by the person providing feedback. On the right-hand side, the AI generates a detailed analysis, automatically populating key insights, and that includes things like tone analysis, so identifying sentiment and tone in the stakeholders' feedback, key questions, so highlighting specific questions directed to us. Primary concerns, so calling out the stakeholders' key issues or areas of interest, and then summarisation is providing an easy-to-read summary that condenses lengthy correspondence into digestible points as well. And as you scroll further down this particular screen, the tool displays all the categories flagged by the AI. For example, if someone's raised concerns about visual amenity, wildlife concerns, tourism, or economic impact, and so on. And for each flagged category, the AI provides a useful explanation of why that category was flagged. And an important point to get across as well is it also quotes the specific parts of the original text to justify its reasoning. So if a wildlife concern has been raised, it'll then quote back specifically why it's flagged that based on the text that the stakeholder has provided to us. And this feature not only helps instill confidence, but it also helps us, it's easier to spot things like any mistakes, or helps us correct any potential errors that might exist. A crucial aspect of this approach is that the original text is always retained. The AI is not replacing any information, it's just enhancing our understanding and making the analysis more efficient. And this ensures that our team retains full control and transparency of the feedback. Again, like I said, combining AI speed and precision with human oversight and expertise. If we go into the next slide as well. Well, we're a networks business, and of course we absolutely love a map, as you've seen them already today. But our AI tool also plots feedback submissions from the public onto a geographical map, and that makes it easier for our teams to pinpoint specific locations of concern. So, and this feature has been especially useful for identifying contentious sections of new overhead power lines, and that allows us to focus our engagement efforts and communication efforts where they're needed most as well. Move on to the next slide for me. Okay, just a spotlight on data privacy as well. So publishing an AI transparency statement on our website alongside clear information in our privacy notice about how we're using AI. And that's been a vital step in ensuring openness and accountability. So, by explaining our use of AI using non-technical language, again, very important with the audience and the novelty of AI as well. We've incorporated best practices and demonstrated a strong commitment to transparency there. That's on our website and easily accessible to people. And we work closely with our legal and data privacy specialists, Sophie and Garnish, to ensure that statement and privacy notice met all the necessary compliance standards while remaining accessible and easy to understand as well. I guess that collaborative approach helped us address questions that we've received from stakeholders and colleagues and the wider public as well. And in having that dedicated resource to direct people to, a web page that they can learn more about how and why we're using AI, that's paid real dividends when we've had inquiries from people who wanted to know more. And it helps us foster trust, it helps enable better understanding, and allows us to keep stakeholders informed about what we're doing as well. And again, that's a living web page, so we've been updating it regularly to reflect any ongoing developments with the system and also answering any questions that we've received. So if we get a question from somebody, we think, well, actually, that might be asked again by somebody else. In the future, we update that web page to incorporate that answer as well. Again, that just reinforces our commitment to responsible and transparent AI adoption. And on to the next one. Thank you. So now on to just the AI-generated reports. Our AI tool has really transformed how we generate and compile reports for our consents and environments managers. And the tool automatically creates comprehensive reports that can be produced in just a couple of clicks. That's perfect for when someone asks how a consultation is progressing, or requests an executive summary of people's feedback as well. And these reports start with a high-level summary capturing the essence of what stakeholders have said and felt during the consultation. They then break down and summarise each individual submission. That includes a unique reference number as well, which allows us to search and quickly access the original text as well. And this functionality has been a game changer, providing clarity and efficiency, but also the depth in a matter of moments as well. So it's not just a helpful feature, it was the cherry on the top for the team, to be fair. I'll go on to the next slide for me. Okay, so how did we do it? I'm going to just talk about what your question is, what's our secret sauce about making this a success? So next slide, please. Thank you. Okay, so at SSEN Transmission, I think it's fair to say that we are an ambitious business, and part of our culture is about trying new things, especially when they have the potential to benefit wider society. And that mindset and culture were central to the success of this project, absolutely. From the very start as well, I think it's important to have clear goals. We needed to articulate to the team what we were trying to achieve. Again, that helps everyone stay aligned and focused on what we're trying to deliver on this IT project. And those clear goals kept us on track and moving forward. But of course, there were things that we didn't know at the beginning as well, but we learned them along the way. And hands-on experience has taught us so much. And one of the biggest lessons was that nothing is beyond your reach in relation to AI, if you're willing to dive in and figure it out together as a team. Moving on to teamwork, that was absolutely key to our success as well. This wasn't just an IT project; it involved our communities team, it involved our IT project team, and crucial contributions from colleagues in legal and assurance as well. A collaboration across all these teams was critical in getting us the best result. There was a comment in the chat earlier about how do people check that things are correct. Testing. Testing played a massive role in this project. I can't stress that enough. We tested and tested again. And we had so many Teams calls debating whether the AI was right and we were wrong, or whether we were wrong and the AI was right. And let me tell you, those made for some very interesting conversations. And I found myself playing referee quite often. But these discussions were vital. They led us to either correcting our understanding or tweaking our AI prompts to improve the accuracy. Speaking of accuracy, we also made a big upgrade during the project. Initially, we were using GPT 3.5, which was good, but then we switched it to GPT 4, and the difference was incredible. And we're likely to upgrade the GPT again this year, so that we're constantly using the latest technology. And it also may reduce our costs as well further. We also increased the token limit to handle larger pieces of correspondence as well. And that's been a game changer for processing feedback, as well as adopting an orchestration system. So we're not running too many AI calls at once, which can cause problems. But the level of technical success wouldn't have been possible without wonderfully talented people, especially a gentleman I work with called Hugo Herrera. So a huge shout out to Hugo for his expertise and guidance. And please give Hugo a follow on LinkedIn. He's literally the author on Dynamics 365 and is a fountain of knowledge, a good person to know. Legal work is another area that we embrace fully. It's the first thing that can kill a project as well if it's not done right. And this was the first time that generative AI had been used in this way at SSE Group. So passing things like our data protection impact assessment and completing the ICO AI checklist were non-negotiables. These processes, they're not just for ensuring compliance, they actually improved our thinking and decision-making on the project, which is exactly what they're designed to do. So I think having a good appetite for these things, compliance-related matters is really key. Being upfront with the public was also crucial. We updated all of our project web pages, our privacy notice, and we created the AI transparency statement for the first time. There are no secrets. We're open about what we're doing and how we're doing it as well, which I think is a fundamental part as businesses adopt the AI with the public. And finally, while the AI tool has transformed how we work, it hasn't replaced the human element, okay? Our dedicated team still reads and checks correspondence, but they're doing it more effectively and a lot faster. And it's important to emphasize that AI is not making any decisions for us. Our people are, okay? Our expert team. And the AI supports them in providing insights and efficiencies, but the final judgment and actions remain firmly in human hands. And that's good for stakeholders, it's good for transparency, and it's good for us. And so that's a win-win. Okay, and to finish off my slots, let's look at impacts and outcomes. Moving on. It's got 2 sections. Okay, so we've analysed 3,000 feedback and correspondence items across our ASTI overhead line and substation projects. It'll be a lot more than that now, actually, with insights and our AI-driven reports directly informing real project decisions, which I'll come on to in just a second. But the AI system has delivered an 89% cost saving and reduced lead times by 84%. We're swapping 222 days of manual effort for just 36. Why that's important for stakeholders is because stakeholders want decisions made very quickly, but because of the volume, it takes a long time for us to go through all these pieces of correspondence and online forms. So actually, we're able to go back to stakeholders with decisions a lot faster because we're getting through the analysis faster as well, which is great. And for the first time, feedback forms and free format correspondence are in one place, which I think is one of the questions in the chat as well. And that enables our teams to take action quickly too. The system's also a commercial success. It's paying for itself. It's about 16 pence per item that's analysed. And again, this project's allowed us to share valuable lived experiences with Ofgem as well, taking part in their consultation on the use of AI across the energy sector. I think there was somebody on the chat earlier talking about that as well. And we've also shared our project with other network companies too. Again, AI is new for lots of businesses, and the more sort of thought leadership and shared learning we can do, the better that is for everybody. And a huge surprise was at the tail end of last year, we won bronze at the UK Customer Experience Awards at Wembley Stadium for best use of AI. A delightful win for the team and not something we thought possible. So yeah, a delight to do that. But most importantly, if we go to the next slide, please. And we have more good news and hot off the press from last week, based on the accessible feedback and insights gathered through not just the AI tool, but other insights as well, in-person sessions with community members as well. We've made further critical decisions to adjust the routes of our Spittal to Bewley power line and our Bewley to Peterhead power line, which will be welcome news to impacted communities as well. So that was announced last week. And again, things like the AI tool just make that a lot easier when we've got data to inform these decisions. And last year as well, this is the latest round, but last year we also made some engineering decisions that will improve the quality of life for local residents as well, such as positioning pylons so that they're not as high and revising our approach to cutting down trees that provide natural screening. And again, this highlights the power of the AI-driven insights and enabling us to make informed decisions that we can confidently proceed with consenting and development, knowing that we've addressed communities' concerns. And if we go to the next slide, again, these are just some examples of the changes that were made last year.
For just 3 minutes, Sean, as well.
That's okay. And again, the next slide, again, just another example of a change that's been made. And that concludes my presentation, just the last slide there, on how we've leveraged AI at SSEN Transmission to support our net zero goals. Just to say thank you, and I'd be delighted to answer any questions. If you're welcome to connect with me on LinkedIn as well. Thank you.
Brilliant. Thank you, Sean. It's a really interesting application. Probably a couple of questions we'll go through probably before we have to move on, but answer again any in the chat that need answering. Sam's asking about, are you able to include the views from in-person events using the same tool as those incoming via digital means, or do you have to combine them both at the end of the process? And I guess a more general question than this is sort of, you know, how do you sort of also value or weight those different inputs? Is there sort of like different ways you look at those and how they feed into your final outputs? You know, something you
that's a really good question, and I'll tell you why. Because you know, there are systems that you can add weightings to, and we actually don't put weightings. And actually, that is a risk for businesses that are adopting AI. Is that if you're in charge of a system like AI, an AI-based system, especially a large language model, then I think an important thing is that you are free to share the results, even if it tells the negative story or it doesn't tell you something that you want to hear. So, you know, we're under no illusion that the projects that we're developing are contentious and impactful on people. And actually, we want to know that, but we want to know why. So again, that's why culture is important. I think that we have a genuine desire to hear. You know, we want more to know. We want to hear everything that people are concerned about projects. And it's important for me that the AI system reflects that. So it just tells the truth. There's a really important thing about AI prompt engineering, which is about how do we ensure objectivity and around the analysis. And one of the things was we actually don't want to tell the GPT too much. We don't want to give it too many prompts because that then creates, you know, it creates bias, doesn't it? So we actually really want to leave it as much as possible, you know, not too many prompts, and the prompts that we do give really kind of light touch. So, for example, it needs to know that we're SSEN Transmission. It needs to know that we're in the north of Scotland. It needs to know that we're thinking about Scottish wildlife, for example. So there's little things that we've told it to help it out. But actually, it gets to the point where you don't want to be giving it too much information, so that we are receiving objective information from the tool. So hopefully that kind of covers lots. It's an interesting point.
Yeah.
It's really important.
I mean, I was just also thinking if there's some troublemaking, enterprising individual could learn what responses to put in to disrupt the outputs to the way they want to.
Yeah, that's also
this opportunity.
That's also another good point. And that's something we had to work around as well. So things like role-based access and actually blocking people from being able to make those changes is an important thing as well. So if someone's a beneficiary of that information, they can't make changes to that system at all. It's all locked down. So that's another good thing that we worked through with our legal and assurance team too, which is how do we ensure ongoing objectivity and that people can't make changes. So yeah, and ultimately I'm the owner of that system. And I've got no interest whether it tells a positive or negative story. I just want the information to be passed to the teams and they can then make the respective decision. I think that impartiality is probably a lesson there, to be fair. When we're building systems, is that team impartial? Absolutely. So yeah, good questions.
And last question, there's lots more, but I can't get through them, unfortunately.
That's okay, I can go back in the chat, yeah.
Finley's asking about what the public reaction to the use of the tool would be.
Well, that's an interesting one. So we do have a couple of people who have maybe objected to the use of AI. That's okay. We've also had people who initially got in touch to say they didn't want to be used by AI, and we've then explained what it's actually doing, and then they've come back to us and said, "Oh, actually, I'm okay with that." And I think that's important to have people on hand, like myself, for example, and my team that I work with, to be able to go back to support colleagues in answering these questions. I think that just emphasises the point that not everybody understands what the AI is actually doing. There's a fear potentially that we're going to use people's information to train large language models. It's not doing that. Having to explain that the system's tenanted and what that actually means in real life. We're not passing anything into OpenAI, for example. But data privacy is important. I'm the same. I'm a real stickler for this kind of thing. I don't want companies having my own data, so I know exactly how people feel. I put myself in their shoes. And I think that's how we're able to answer questions very thoroughly, quickly as well, and honestly. The other thing, again, the AI transparency statement, we've been able to signpost people to that, knowing that it answers pretty much all the questions that people might have. And if it doesn't, we answer the question and then we update the web page because we know that question might come up again. So I think that's benefit to me because I look after a website, but even if I didn't, I would go to somebody who looks after a website if it wasn't just me. So I think that's important too. And you're also making me think today as well about as we bring on more AI systems into the company, we're probably going to have the equivalent AI transparency statement that I have for every project so that people can understand using non-technical language what's actually going on here. I think that's really important.
Well, brilliant. Thank you very much, Sean. I think we'll move on to the next piece, but please answer anything you can find in the chat. Great. So I'm just going to move the slides on to our final speakers. So I'm very happy to introduce Dan Clark, who's the Head of Innovation at the Energy Networks Association, and Edward Sharkey, who is the Director for AI and Solutions at Baringa. And they're going to be talking about their new AI-powered tool, which utilizes installer images to streamline the approval processes for domestic low-carbon technologies. So please take it away.
Thank you very much, Stephen. So just to give a bit of an overview of who ENA are and how this project came about, we represent the electricity networks across the UK. If you just pop to the next slide, I've got a handy map outlining who we are and what we do. So we represent all of the electricity networks, but that's both transmission, as you just heard from Sean, and also the distribution networks, which bring electricity to homes and businesses across the UK. And that translates into a lot of customers and a lot of miles of wires across our membership. And we support them in various ways, including how to integrate low carbon technologies, which is why this project came about. So I'm just going to set the scene and talk about some of the challenges we were facing and why we thought an AI solution was necessary. So if we skip to the next slide, we're moving from a sort of a one-directional power system where we have large generation pushing energy out to homes and businesses across the country to something that's much more decentralized, decarbonised, ever more digitalised, and also ever more democratised as consumers start to participate in the energy system. And what that means is lots more LCTs on our network. And just to give that some context, there are various government targets around low carbon technologies. There's a target for 600,000 heat pumps per year. We're currently around 70,000. So so an order of magnitude higher. I'm not going to get off topic with some of the electric vehicle discussion, but there is a target to move away from ICE vehicles. There's over 1 million vehicles sold in the UK every year. So you translate that, if they all move to electric, the number of charge points we'd have on our network would be greatly increased from where we are today. And what that means in reality, if we move to the next slide, just to give how that means that things have evolved over time. Back in the 1960s, we had electrical lights. A lot of people had an electric fridge. A lot of people got their first television for the 1966 World Cup final, which basically means even in the 60s, we didn't have that much TV until the second half of the decade. That means very low power and only over a few hours, highly predictable demand. As we move forward into the 1990s, if we click through, the number of consumer goods in the home has dramatically increased. We now have things like electric dishwashers and washing machines, the electric kettle, quite an interesting one, 2,000 watts of power, but only for a few minutes. So in the 90s, when people still used to watch TV to a schedule, the energy networks would study the schedules and work out when everyone was going to jump up from their sofas, Coronation Street's over, and go and put the kettle on, and we would push extra power to the network. So still relatively low amounts, but also still highly predictable. As we move forward into the 2020s, no one watches TV to a schedule anymore. But not only that, we also have these low carbon technologies, in particular EV charge points, heat pumps, solar panels and battery storage. And they're drawing much more power over much longer periods of time, or in the case of solar panels and batteries, potentially pushing power back to the networks. And so that just makes it a more complex and dynamic picture for networks to map and understand. And so they really need to know where these low carbon devices are being installed so they can actively and proactively manage the network. So that's the challenge we faced. If we move on to the goals of the project, we were looking at a way to try to better guide installers and support them. Previous to this, we had effectively paper forms where people could print off a document, literally fill it out with a pencil and post it back. Not a very 21st century solution. So we needed it to better guide installers. We wanted it to be faster for customers and crucially provide that accurate data back to DNO so they could plan effectively. We knew it needed to be an efficient system, so we have API data transfers between installers and networks. We need it to be smart, and this was the real key. We need to be able to make automated approval processes, and as we'll come on to in a moment, that meant that we needed certain AI solutions for particular aspects of the connections process. And ultimately, we needed to make sure we had safe installation. So is the assets in the home right sized for the equipment that supports those assets? So we took all of those objectives and we turned them into this concept, which is the Connect Direct vision for what we are looking to do on the next slide. So the concept is that we have installers feeding information either through a web portal or through an API in exactly the same service, whichever way around that works. We also have a database of all of the devices that are for sale in the UK. And so the installer just needs to tell us which device they are looking to install. And we can pull all of the technical data from the database, a few other bits of information about where they're looking to install, who the customer is, and also a picture of their cutout. Now, the cutout is the link between the electricity network and the consumer's home. So everything beyond the meter, beyond the cutout is the responsibility of the consumer. Everything our side is the network's responsibility, and the cutout is the interface in between. And it's really important that we understand the health of that cutout, the age of that cutout, whether it's right sized for the equipment being installed. So that image is a key part of our connections process, and we need to be able to assess that in a way that could give instant approvals. Hence the solution for AI. And I'm delighted to be joined by Ed Sharkey from Beringa, who's going to go through how we developed that part of the system.
Brilliant. Thank you, Dan. And massive apologies because I almost cut the first edition of Dan's pack, which removed that fantastic slide art. So yeah, a little bit about Beringa. I bet I won't dwell on this slide, but ultimately, I guess what we do is we're obviously a consultancy, and what we bring together is a level of energy expertise combined with our solutions and AI expertise. And as you can see, similar to others on this call, we work quite broadly across the energy industry. With a variety of you actually on the call. So we jump to the next slide, please, Stephen. So I won't dwell on this slide as well because I think it's not a particularly good summary, but in general, I think just to build on some of Dan's comments, I think cutouts aren't necessarily a well-known electrical component. There's no publicly available materials on it. And I think one of the big challenges of this project was actually getting hold of the data. Overall, we received excellent performance with the models. We tested and validated this with all ENA members. The test result, or the test images that were provided by the members, along with the model weights and a methodology document, was provided to the kind of wider group as part of the sort of finalisation of it, which I will go through in further detail. So if we jump to the next slide, actually, please, Stephen, and I can jump into some of the data. So yeah, as I said, data was a key thing for this. So obviously we approached this as an image recognition problem, and what we needed to do was look at how do we fundamentally train these models or fine tune these models on basically a data set that only kind of exists within sort of members and installers and other areas. We were kindly provided two different data sets, actually. So one was a more generic data set that was representative of, I would describe as cutouts in the wild. So cutouts that kind of are probably not brand new or not like hung on a corkboard, for example. We were also provided a sort of lab set from one of the kind members as well, which was actually just a variety of different cutouts, all hung on corkboards and very great lighting, no spider webs. They were all in pristine condition. So what we initially started to do is we basically started to formulate this problem, working with members. And basically we followed there's a great document on the ENA guidance document in terms of some of, and we've put in a link when these slides go out, that will be available. But basically that like establishes the different criteria for the different cutouts. So a lot of the labeling and tagging was done in coordination with some of our energy colleagues, as well as also myself, the team, and going through all those different images. And basically, so we jump to the next one. Next slide, please. Perfect. That's it. So jumping back to those lab images, I think one thing to call out, so that was our initial approach, and one of the things we looked to do, like sort of firstly, I guess one of the conclusions of that is it was although a fantastic, potentially fantastic data set to identify the nuances between some of the different cutouts. The problem was, as I'm sure those familiar with any of these modelling or approaches and the hands-on experience, it wasn't a very representative data set for actual cutouts in the wild. And what I mean by that is that in general, where you have them in people's homes, or the basically where you're being shown kind of images from the installers that they're taking, there can be a combination of sometimes on new builds, they can be exposed slightly more to the elements. There can be lots of spiders, or if they're in kind of people's sort of utility rooms, we probably get like an extensive amount of shopping bags and covering the different cutouts, so they can be slightly obscured. So as I said, we moved away from the lab images because as you can see from some of the results, it didn't get particularly like fantastic results when we actually went to test on some of the holdout set that was provided by the members. In terms of the models we approached, we obviously looked at a variety of different models. So we looked at some ConvNets, as well as actually also we did look at VIP, which is one of the transformer models. In general, the EfficientNet model, not surprisingly, as it's one of the best-in-class models, was our top-performing architecture, and it's the one we took forward. I think in terms of the other things just to call out in terms of like well, first of all, the model training, obviously the obligatory had to include a train icon for this. But I think one other thing to call out from some of the data processing for the imagery, we spent an extensive amount of time on some of the data augmentation techniques. So looking at the skew, the rotation, the translate, the blur, and a variety of other methods to try and avoid overfitting, and again, help the models basically generalize. And where we landed is we basically looked at a pipeline of models to kind of start looking at detecting, first of all, is there a cutout actually, so validation that the image is actually in fact the cutout. Then, as I showed on the previous slide, we were looking at the modern or not modern split. And then what we were also looking at in the third model was looking at the general condition of the model. This is a bit of a deep dive on obviously the machine learning module as part of Connect Direct. There is obviously quite an extensive additional platform that I encourage you to message Dan Clark about, or others at the ENA or other party members in terms of looking at the wider application and the wider process of how the application is being used, but just focusing purely on the AI side for the moment. So if we jump to the next slide, please, Stephen. Yeah, so basically, I think just showing some more imagery on this, and I guess where we got to overall. So basically, yeah, the models achieved pretty excellent results throughout. I think obviously I spoke through some of the interesting things we found through the process. I think the data augmentation approaches, I think the pivoting away from the lab images as well as also using some of the best in class models led us to getting good performance on our distinct different models as part of the pipeline. I think hugely appreciative of all the help and support from obviously ENA, but all members involved with this. It was a huge, massive collaborative effort where the different members were able to also, when we came to testing and validating of some of the results of the models, were able to provide some unseen test data as well, which was great. And as I said earlier, we were able to basically provide model weights, the image results of all the different test sets that we were looking at, and as well as all of full methodology of the document, which was made available to all members on a SharePoint in order to be for full transparency and evaluation of all the modelling. So we jump to the next slide, please. Again, this is keeping within the scope of just the AI module, rather than looking at quite the large extensive platform that connects to I think 8 different members and has direct connectivity for a variety of different data sources, and obviously outbound connectivity, as well as a variety of other factors and integrations. One of the benefits of EfficientNet is, as for any of that have read the paper, is very efficient. So one of the things that is useful in that is that it's a great performance in relation to the size of the model, which lends itself well from an architectural perspective for us when we're looking at inference time. We're able to run it in a serverless pipeline. So as you can see, we're able to run it within an AWS Lambda. To date, we've had 45,000 applications through the platform. And we also bring a runner support for this. So we basically any issue or any escalation that via either it's an installer or if it's an ENA member, we respond and interact on behalf of ENA as that support team. So, but in general, we found the feedback to be good. We've had a couple of examples and some feedback in relation to from installers in terms of the angles or the distance of the cutout in terms of how the model reacts to some of that. And I think it is tricky sometimes where there is either the cutouts are in locations in houses where it basically is in an obscured location or covered in shopping bags, or potentially there are extensive amount of other elements that come into play on there. But what we've done to address some of that feedback already is in terms of actually some of the ENA platform has some guidance and kind of basically direction in terms of the use and how you should take the images to best work with some of the models, which we've updated within the platform. In terms of what's next, we've also been in active discussion with members around what we want to do more of, maybe what and what kind of additional options. So I think there's general interest in looking at particular fuse type detection, and potentially also looking at a transition from modern/not modern into a broader multi-class problem, looking at, and I think I showed some of them earlier, and they're available in the ENA guidance document, but biscuit tins are a particular one of interest, as well as also potentially black resin cutouts over a particular amperage as well. So we're looking at assessing options of how the platform will, I guess, continue to evolve. And also with different cutouts coming and different changes coming, it is an ongoing sort of collaboration that, we've had good success to date with. So I think we've jumped to the next slide. I don't know how I'm doing with time, Stephen. I don't know, Dan, was there anything you wanted to throw in?
Yeah, I think in summary, I would just say that we knew it was possible to build a platform to pick up applications and do that in a digital way. We knew it was possible to do some of the elements that we do around the platform. We thought it might be possible to automate the technical information from the database and even get an API out to the Energy Inquiry Service to automate things like MPAN numbers, which we've also done through this project. What we really didn't know at the start was, will the AI be capable of recognizing the cutout and making an affirmative decision one way or the other? And that was a really critical thing. Without that, we wouldn't be able to give that instant access response. So it was crucial to the success of this project that the AI worked and was reliable. And not only that is that the case, but actually we found now there's appetite to go further with the AI, as Ed has said, and to recognize more cutouts and have dynamic decision making off the back of that. So really interesting project, and hopefully a good use case to describe how AI can work in practice.
Perfect.
Brilliant. Yeah, I think this is a really interesting use case. But I guess the other thing comes to mind is that it looks like it could be applied to quite a few other areas, right? I mean, off the top of my head, would like things like maybe smart meter installs or other low carbon technologies. Like, first of all, I guess, are you thinking about that for other applications, and how easy would it be to transfer the learnings from this to a new application?
I mean, I've got a view from an AI model perspective, so I can go first on that one, Dan, and then you can give a build. So yeah, I think it's a great question, Stephen. I think for me, yeah, I think out of all types of AI technologies at the moment, I think image recognition is pretty well understood, and obviously for anyone using their iPhone or Android, or there are other devices available, and using facial recognition to access the phone, I think we know that there's a lot of genuinely excellent models, and I've obviously referenced that paper for EfficientNet and what that's able to accomplish, and therefore what that can be applied to in different domains. Our first model, actually, where we do cutout or sort of not cutout, or trying to actually establish if it is a cutout, directly to your point, Stephen, smart meters are a huge part of that, where we do get quite a lot of smart meters uploaded which are not cutouts, and therefore we have to say that's not a cutout. However, if you inverse our model, we actually technically have a smart meter detector. But so I feel, and I think the key thing for me on a lot of this is, I think the techniques of modeling is there. However, what I think, particularly working with ENA and members, what is possible with the collaboration is you can get access to these data sets that aren't publicly available, that aren't possible without that deep collaboration and expertise, whether it's the guidance documentation or the tagging, it's the other areas. So I think, given the right combination of the institutions, which we've been very fortunate to have in this project, I think you could do something like that, and you could obviously take it further.
Yeah, I absolutely agree. And I think thinking about the wider business case, saving a site visit for a DNO or any other business is a huge time and allocation of resource saving. It takes a long time to travel to do what is quite a simple job. And so if the installer or even the customer can take that image and have something process that instantly, it speeds up the process for everybody. So there's a lot of potential there for other applications, and we have been talking about what else we could do, whether we can start to recognize some of the writing that's in the meter board and other bits and pieces like that. We're also looking at some augmented reality. So could we use it for training, where you could recognize the particular type of cutout and then effectively load augmented reality training to say how to fix it or change it and things like that. So there's huge potential that we're looking at through the innovation pipeline. What's great for us is that we could get something practical working that then we can say to all the DNOs, this works, let's go even further, let's do even more. And to Sean's point earlier, networks have a reputation of not being that forward looking, and I think through Sean's project and perhaps our project, we are showing that we're bucking that trend and really advancing networks' technical capabilities.
Yeah, definitely. And I was just thinking things like the automatic asset register, obviously bringing all the data together for those distributed resources, and whether or not something like this could, especially with the commissioning of sort of heat pumps, which can be a big challenge.
Indeed.
So it could be a really useful tool. I have a slightly technical question. I was great to see the data augmentation. I'd be interested in how much effort to sort of results there was in terms of how much of that do you need to be doing? Quantify that.
Sorry, the question was how much data augmentation we needed to be doing.
Yeah, I guess how much effort is how many sort of extra images is gives value to sort of the extra accuracy, if you will.
Yeah, I mean, I was so interesting when we obviously looked at efficient net, one of the things that jumped out for me was actually there was pretty much no difference in terms of accuracy between the pre-trained version and the non-pre-trained version, which is quite probably representative of some of the pre-trained elements probably being publicly available information probably weren't that fantastic for some of the cutout view would be how I would view that. In terms of the data augmentation, yeah, that was a lot of where our effort was spent, because ultimately we're standing on the shoulders of giants with the efficient network. However, where we have to come into play is obviously more in that custom data augmentation pipelines, and I guess fighting and addressing overfitting and ensuring. And I think we saw that through the iterations and journeys we went on, where we, as much as you try and distort a corkboard, it's still a corkboard. So, and actually, therefore, that was something we moved away from when we actually adopted that kind of more representative general view. And that's where that augmentation is still very important. In terms of the total sampling, yeah, it's always really interesting. I think we probably saw like so we used all the data we had available to us, just because I think we were in the fall. It was a team effort to get to that point, to get the data, and I think since we had it, we wanted to use it. However, I think roughly I probably saw quite a substantial jump in performance, probably around the 3,000 image mark randomly. And I don't know that it's not a particularly like kind of scientific reason for why that would be, but I guess that's just that obviously is where the relevant loss functions converged to the point where it was reaching that point. So I don't think there's any set rule you can really take away from how much data is the right amount of data, and it is a case of just getting a good amount of data and getting the right data. We did have an extensive amount of lab images, so we had a lot of images of the modern cutouts and the corkboards, and I think it becomes a question of not just how much data do you have, but do you have good data? Do you have that really representative data? Because I think you are trying to. There is a true approximation of the perfect cutout that exists, and you are trying to approximate that through having the most representative data that's available to you in that sense. And I think we got that, and I think that was through, as I spoke earlier, that deep collaboration with the party members to get to that point, which is fantastic.
Well, fantastic. Yeah, this is great. This is a really interesting application, and so thanks for sharing that. I think we're now pretty much the end of all the talk. If there's any other questions, please put them in the chat, and hopefully everyone, Dan and Edward, can answer those. Thank you again, both of you, for a brilliant talk, and thanks to everyone speaking. I've just got a few wrap-up things I'll add to the final slides, so then everyone can go. Thank you, everyone. I just wanted to put a slide up. I'll not go through it because we've tied on time, but there is some other applications, especially with LLMs, which are looking at sort of the certifications and trying to improve things in these areas. But I just wanted to sort of address a few things which have actually come across in pretty much all of these talks and in the chat. AI risks is obviously a very hot topic at the moment, and lots of regulation lots of different governments are looking at regulation in these areas. There's obviously a new administration in the US, and we'll see how things change there. Data centers are going to be key, and they're not only a key issue for AI, but they're obviously a key issue for the connections process themselves. Skills was mentioned, and obviously these tools can help augment the skills that are already there and hopefully support others workers, and also help maybe create other opportunities. But obviously there's going to be an issue with maybe having the right technical abilities there. And data and just as the last talk showed us, getting that data and getting it shared in standardized forms is key. There might also be a role here for sort of synthetic data, and obviously the augmented data that was used in the last talk is sort of one version of that. Quickly to share, we have a knowledge hub, which is including a lot of resources we've collected from both the project we were doing and from other places. So please have a look there. We are interested in feedback on this, and we obviously would be interested in things that might be useful to add to the knowledge hub. Scan that with the QR code there. We will be there's a couple of events where advice will be involved in. We're running a workshop at AI UK, which is in the 17th, 18th of March. There will be a sort of obviously energy sort of decarbonisation presence there. We will have a close down. I think we'll have to share more details on that while we finalize everything. So please look out for that. And finally, although this isn't advice, there is a couple of events coming up in our Value in Energy Data webinar series. We've got one talk at the start of February on commercial energy demand, and a second talk from University of Bristol on the 19th of February, looking at digital twins and how sort of lessons for innovators, policymakers, and infrastructure operators. So that is everything. I do encourage you to ask further questions of everyone. Send messages to all of us and the speakers. It's been a brilliant session. I've been very pleased to see the variety of applications of AI methodologies, however we define AI, and also the different, the explosion in the interest in these areas. So it's been brilliant to see that. Thanks to everyone in the chat who's been sharing their questions and insights as well. We will be sharing the slides from today to everyone who's registered, and we'll be putting this recording on our YouTube and on the Knowledge Hub as well. So keep an eye out for that if you're interested. So again, yeah, thank you to everybody. Thanks to all the speakers who've chatted today. So to Adam, Andreas, Sam, Sean, Dan, and Edward, and to Beth as well, of course, and to Sam, who's been helping me in the chat. So it's been a brilliant session, and I want to thank you all, and hopefully see you again in the future. Take care.